see what we have here. So it says find the area of the region using a left Riemann sum bound by this curve and the x-axis. So the function that we're talking about is e to the x, and then we're trying to find the area from 1 to 3 with 6 subdivisions, with 6 rectangles. So it might help us if we first just do, if we first like make a little graph of what's happening here. We should have an idea of what e to the x looks like, and we should be able to come up with a rough sketch to help us out for this problem, or at least in the theory of this problem. So if I have it where this is, let's say, I don't know, let's say this is 1, right? Well, better yet, let me make it a little bit better to scale. Let's say that this is 1. This is 2, roughly. If I do this as roughly as I can, 3. Okay, that's fine. And now, e to the x. What does e to the x looks like? So let's get a rough sketch of e to the x. So at 1 is all I really care about. So let's say that this is e right here. This is e to the 1, right? Then I'm going to have e to the 2, let's say somewhere up here, and then e to the 3 is much higher. Let's make this a little bit better. Let's say e to the 2 is here for the sake of being, so I get that exponential curve when I put e to the 3 up here. And what do I want to do now? I want to find the area of the region using a left Riemann sum bound by 1 to 3 with 6 subdivisions. So the first thing we should do is we should divide this region up into 6 equal pieces. So 6 equal pieces, each piece is going to be what? So 6 equal pieces, the length from 1 to 3 is 2, right? Delta x is going to be 3 minus 1 over however many rectangles there are. That's the 6 subdivisions. That's 6. 6 subdivisions, 6 rectangles. 2 by 6, delta x is 2 by 6, so delta x is 1/3. And I know that then the width of each one of these rectangles is 1/3. And essentially that just means I want to divide this up into 3 equal parts like this. And then this part up into 3 equal parts. And what I'm going to do is I'm going to make it so we could easily just go from a left to a right. So we're going to do 2 problems. So we'll do left Riemann sum, and then we'll do a right Riemann sum. And maybe if we have time, we'll do a midpoint. Let's see. Okay, so now left Riemann sums. So if I do left Riemann sums, right? Well, what are these points? This is 1 and 1/3. And then this is 1 and 2/3. This is 2 and 1/3. I'm marking out these intervals, and then 2 and 2/3. Just keep adding 1/3 to each piece, and then 2 and 3/3 is 3. 2 and 1, right, is 3. So now what? I want to do left endpoint, so e to the x, right? Let's say that this is the curve e to the x. I want to go and I want to say, let's see a left endpoint rectangle. The first one is going to be this point right here. And I'm going to go to right here, the next division. And that's going to be one of my rectangles. Then I'm going to go and I'm going to have this rectangle right here. And then that's going to be my other rectangle. And I should have a total of 6 when I'm done with this process. So the next one is going to look like that. And I want to be sure that I'm able to determine the height of each one of these rectangles, which I will be able to. The width of each one of them is for sure 1/3. Right? Because I got delta x. And now this is what my 6 rectangles will look like when I'm using left endpoints. So I started off to the left. I started off at 1. Now let's find the area of each one of these. So 1/3 is going to be the width for each one. And I'm summing along each one of them. So what's the width? Well, what's the height? The height of this one is e to the 1. So this area is 1/3 times e to the 1. That's the area of this first rectangle. Now the area of the second rectangle, right, is going to be, the width is 1/3 times, now the height of this is e to the 1 and 1/3. or e to the what? What's 1 1/3? 4/3 plus 1/3 e, so that was this rectangle is this one right here, right? This height is e, this function is e to the x, right? This curve, and then this height right here is at that point right there. So I keep going like this, and then it's e to the 1 2/3, which is 5/3, plus 1/3, right? And that was this rectangle right here. And I have to do this a total of 6 times, so I have 3. E to the 2, right? This is the rectangle I'm on now, and that's e to the second, or e to the 6/3, which is just e to the second. E to the second, plus 1/3 e to the 2 1/3, which is e to the 7/3, right? Plus, and that's this rectangle right here, 2 1/3, right? 6 7/3, 1/3 times, and then the last rectangle is this right here, which is e to the 8/3. And whatever this is an approximation for the area underneath the curve, and that would be your answer, whatever this is. You could factor out the 1/3 and then just use the calculator to get the e to the 1 plus e to the 4/3 plus e to the 5/3 plus e to the second plus e to the 7th plus e to the 8/3. So you don't have to do that multiplication each time, right? You could factor out that 1/3. And this is using left endpoints, and you put the whole thing, the e to the 1 plus the e to the 4/3 and so forth, and that would be the approximation using left endpoints. Now let's get the approximation using right endpoints really quickly. Let's see if we can do this quickly. So using right endpoints, I'm going to delete everything that we did with using left endpoints. And right endpoints is very similar, only you start off to the right rather than to the left for the height of each rectangle. You're still going to have 6 rectangles, they're just going to look slightly different. So let's see what they look like when I do right endpoints. So I'm going to leave the curve e to the x up, and I'm just going to change it around if it were right endpoints. And again, all you do is you start off to the right, where this is the height of your first rectangle. And that's going to change things because that's going to be an overestimation of the area underneath the curve. So that's your first rectangle, and that's 1/3 times e to the 4/3 plus, and then it's 1/3, the next rectangle, right? The height is going to be up here. E to the 5/3 plus, then the height is going to be e to the second, this rectangle right here, and then, okay, so 1/3 times e to the second is the area of this rectangle right here, and then the area of the next rectangle is going to be e to the, what, 1/3 is the width of that rectangle, e to the what, 6 7/3, 7/3 plus 1/3 e to the 8/3. And then you keep going. Let's see, so this is going to be this one right here is this, and then you have e to 2 2/3 is right here, and then the last one is going to actually be 3. And again, it's going to be the 6 rectangles, but only you end at the end point for the interval in this case, and you begin 1 over when you're using right endpoints, and you end at the end. When you're using left endpoints, you begin at that beginning point that you're starting. In this case, you didn't. You started with the height being over here for right endpoints, and then you have 1/3 e to the 9/3, which is e to the third. And again, you would just factor out the 1/3, and you would find out an approximation for the area, which would be an overestimate in this case, because it's above the curve, that excess area. All this shouldn't be included for the area underneath the curve. But either way,